This week, we will be talking about geometric sequence. If you look at this sequence, 3, 6, 12, 24, what do you notice? Please pause the video and think about it for a minute. Hopefully, you discover that one term of the sequence is multiplied by 2 to get to the next term. This is an example of a geometric sequence. A sequence made by multiplying by the same value each time. So multiply by 2 to get to 6. 6 times 2, you get 12. 12 times 2, 24. 24 times 2, 48, so on. Now let's try to figure out how to form a formula for geometric sequence. For this sequence, the first term is 3. To get to the second term, you multiply 3 by 2 to get to 6. So you multiply 3 times 2 to get to 6. For the third term, you multiply another 2 to get to 12. So in order for you to get to 12, you have 3 times 2, which you will get 6, but then you multiply another 2 and you get 12. So for the fourth term, which is 24, how do you get to 24? You have 3 times 2 times 2, and then you multiply another 2 and you get 24. So are you starting to notice the pattern? Now if you want to figure out, let's say, 8th term this time, it must start from 3. Then you're going to multiply by 2, by 2, and so on. So how many 2's do you think we need to multiply? Pause the video right now to think for a minute. Hopefully you realize that we need to multiply 7 2's. So it will be 3 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 7 2's. So we write, in other words, we can rewrite as 3 times 2 to the 7th power, which you will get 2 to the 7th times 3, 384. So if you want to find the general equation u sub n, it will be 3 times 2. Now how many 2's do we need? We need n minus 1 2's we need. So it will be 3 times 2 to the n minus first power. So to generalize for any geometric sequence, basically you need two things, u1 and r. Now u1, of course, is the first term. Hopefully you know that by now. And we will call r as common ratio or multiplier. Sometimes common ratio is not so obvious. For example, r could be, multiplier could be like 1.5. In that case, you need to now here's a little trick that you can use to find r when it's not obvious. All you need to do is you just need to pick a number and divide by one previous number. For example, for the equation that we've been using, so let's say we pick 6. So R is 6, and then you pick the number previous to it, which is 3. So R will be 6 divided by 3, which is 2. And it's kind of obvious for this one, it's multiplied by 2. But if the common ratio is not obvious, you need to do a little bit of a division to figure out what R is. Okay, so let's go over on an example. Okay, we just have 2 questions, A and B. So first, let's see. So to find the formula, we have to find the formula. We need to identify U1 and R. So let's try that. What is U1? Well, U1 is the first number, so it's 2. Let's find R. What is R? Well, to find R, again, in this case, it's pretty obvious, but let's just use this method. You pick a number, so I'm going to pick 6, and then you're going to divide by the previous number, which is 2. So 6 divided by 2 is 3. So this sequence, you're multiplying by 3 to get to the next number. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and so on. So what is the formula? So U sub n equals, so right here, here's the equation. What do we need? U1. U1 is 2 times 3 to the n minus 1. That is your answer. Now, next question, to find the 10th term, we're just going to simply apply the equation that we just found. So, we're just going to apply that. So, U sub 10 equals 2 times 3 to the 10 minus 1. Now what is 10 minus 1? It's 3 to the 9th power. Okay? Now you take out your calculator. Now what do we do next? Personally, I will do, well, we have to take care of the exponent. So we gotta do 3 to the 9th power first. Okay, so let's do 3. So take out your calculator, do a 3 to the, now this is the exponent button. Hopefully you have the calculator with you. 3 to the 9th power. Some of the exponent button I've seen x to the y. I think something like that. And there are some different calculators have a different exponent button, but mine is 3 to the 9th power, and you should get, let's see, 19,683. Okay, so we need to do 2 times 19,683. And the answer will be 39366. Now, we also need to talk about the cases when our common ratio is not a positive integer. As I said before, sometimes R could be negative or even a fraction. So let's explore those cases. First, let's explore when R is a fraction. please consider the sequence, this 28, 14, 7, 3.4, 3.5, and so on. If I ask you to analyze this sequence, you might say that the sequence is dividing by 2, which is correct. However, in geometric sequence, we need to express the formula in terms of multiplication. So we are going to stick with the original method of right here to find R. R equals U2 divided by U1. So in this case, U2, which is this 14, that's U2, and 28 is U1. So it's going to be 14 divided by 28. And if you do the reducing math, it's just going to be 1/2. In other words, R is the value is going to be 1/2. So if I were to ask you to write the full formula, it's going to be U sub n equals, right here is the formula, U1, which is 28 times 1/2. I'm going to put it in the parentheses because it's a fraction, to the n minus 1. And this will be the formula. Now, let's consider when R is negative. Please take a look at the sequence for -8, 16, and so on. Now, what's happening here? Again, let's just jump right into figuring out what R is. So R equals, the multiplier is going to be U2, which is -8. So -8 divided by U1, which is 4. Now what's -8 divided by 4? So it's -2. So in this case, the R common ratio is -2. So if I ask you to find the full formula, UN equals, again, here's the formula, U1, what's U1? It's 4 times, let's put in parentheses because it's a negative number, -2 to the n minus 1. This will be the formula for this sequence. Well, this concludes the video instruction for the week 2. If you have any questions, please contact your teacher. Take care.